In this video, we'll draw the Lewis structure for Na+, the sodium ion. Before we do that though, let's take a look at just Na, sodium, as it's found on the periodic table. So if we have just Na, that's a neutral atom. That means the number of protons and the electrons, they're the same. So if you look at the periodic table, you'll see sodium has 11 protons, and that means it's going to have 11 electrons. And those electrons are going to be distributed in energy levels. We put 2 in the first energy level, 8 in the second, and then the third has 1. That means the highest energy level is the third level with 1 valence electron. So if we were going to draw the Lewis structure for just Na, sodium, we would take 1 electron and put it right here, and we'd be done. So that's the Lewis structure for sodium. When we have Na+, the plus means that we've lost an electron. So we'll take that electron, get rid of it, and there you have a Lewis structure for Na+. So if we're thinking about our sodium here, this electron goes away, and then we have Na+. We can also get rid of this shell here, this energy level, because it doesn't really make sense now. Here's where it can be a little bit confusing, because now that we've lost that third energy level, the highest energy level has 2, 4, 6, 8 valence electrons. That means it's very stable. Having 8 an octet gives an atom stability. So conceivably, we could write Na+ with 8 valence electrons around it for its Lewis structure. However, that's not really done, and here's the reason why. When we have sodium, Na, it's losing this electron when it bonds with other elements. So for instance, NaCl, sodium chloride. Sodium has the 1 valence electron, and then chlorine, which is in group 17, sometimes called 7, has 7 valence electrons. When they bond, sodium transfers its 1 electron to the chlorine. Now the chlorine has 8 valence electrons, very stable. And remember, when we lose 1 here, this becomes stable. It also becomes positive. And here we have our sodium positive. That's our Na+. And chlorine, it gained a negative charge. It gained an electron. It becomes negative. And that's an ionic bond. We have the negative and the positive attracted to each other. That's a pretty strong bond. We should put brackets around the Cl- by convention to show that the sodium, when it became Na+, lost its electron to chlorine. And that would be the Lewis structure for sodium chloride. Note here again that the Na, it's plus, so we didn't write anything around it. We didn't show any valence electrons, but we do know that in that second shell there really are 8, and that's why it formed the chemical bond. Let's clean things up a bit. And there you have it, the Lewis structure for Na+, the sodium ion. This is Dr. B, and thanks for watching.